All right, so we're going to solve rational equations today. Rational equations have lots of fractions in them. It says solve each equation and remember to check for extraneous solutions. Yeah. That's not going to hit us today so much as it will be in part 2 tomorrow, but I'll talk about what those mean. So normally when you are solving an equation that has fractions that's numbers, you would get common denominators and do all of that. But there is a trick where you don't have to do common denominators or do anything like that. We're going to get rid of the fractions. So what we want to do is we want to take the entire equation times something that will get rid of all of our denominators. So if we look, I've got x and I've got x squared. So we're wanting to cancel those out. We're going to go with the higher power. So I'm going to put the whole equation in parentheses, and I'm going to take it times x squared over 1. I don't need to change the denominators, just the numerators. And then we distribute that out to all of the fractions, and we rewrite it. So I'm going to have 5x squared over x squared equals x squared over x plus x squared over x squared. And so what we did was we created these such that we're going to cancel out all of the denominators. So these x squareds are going to be completely gone over here. That's going to leave me with 5. If I have x squared over x, what will happen when I divide those?
X.
Just becomes an x. So basically you cancel out this x with one of those and you're just left with an x. And then x squared over x squared would cancel out and leave you with 1. And now look at this equation. How hard is this? 5 equals x plus 1.
X equals 4.
So if you subtract 1 from both sides, which you can probably do in your head, we get 4. Now when it talks about checking for extraneous solutions, it's talking about domain. Whatever we get here, it cannot make the denominator 0. So if I put 4 in here, I get 16. Put it in here, I get 4. We're okay. This solution works. It's not going to make any of our denominators 0. So when it's talking about extraneous solutions, that just means make sure your denominator's not 0. Okay, that's what that's talking about. We'll make a little bubble there. And I don't think that's going to hit us today so much as tomorrow, but I'll just talk about it. That way you know that's what it's talking about. Okay, so if we go on to number 2, I have v, I have 5v, and I have v squared. I need to pick something that I can multiply by the whole thing that'll get rid of all my denominators. So I know I need a 5, and then v squared we also will need, and that'll get rid of the v and the v squared and the v there. So I'm going to do 5v squared and then just over 1. So when I multiply this out, it will not change the denominators because you're just multiplying denominators by 1, but then it'll put a 5v squared everywhere. So we're going to have 5v squared over v squared plus 5v squared over 5v. I don't know why that's such a tongue twister for me. And then 5v squared over v. And then we're going to cancel out stuff to make a simpler equation, and it'll get rid of all of the fractions. So we'll get rid of these v squareds. That leaves me with 5. And then this all cancels.
No, not the
Oh, wait, the v does not. Hang on. So you're right. V squared over v would just become, the v would cancel with one of those and would leave me with v. And then over here, this v will cancel with one of those and leaves me with 5v. Okay, so I've got v's on both sides, but this is definitely a lot simpler. How do I get all the v's on one side? Subtract the v. Very good. Such good students. So we get 5 equals 4v. And then what do we do?
Divide by 5.
Or how about 4? So divide by 4. And we can just leave this improper. 5/4 equals v. If you want to make it 1 1/4, you can. 1.25 would be the same thing. But on the answer keys, it's always just going to be an improper fraction. Okay? So let's move forward and see what else we're going to have. The numerators are looking a little bit more complicated down here, but the denominators are not so bad. So we're focusing on the denominators. We want to get rid of those. So yes, you are right. We're going to multiply by r squared, and I'll just put that over 1. And you're not going to want to distribute this out. I'll show you why. So I'm going to put r squared and then parentheses 8r minus 12 over r squared. Do you see why I don't want to multiply this out? Because the r squareds are just going to cancel. And then I'm going to have equals 4r squared over r minus, and then I'm going to put r squared parentheses r plus 4 over r squared. So I don't want to distribute it, really. Like, I gave it to all the pieces, so in that way I distributed, but I'm not actually multiplying these out, because these r squareds are going to cancel and just leave you with 8r minus 12 equals, and then this r squared, one of the r's here, I'll cancel this r here, so I'm left with 4r, and then these r squareds will cancel, and then this minus does distribute to the r and to the 4, so you're going to have minus r and minus 4, and that is the one place people usually make mistakes. If there's a minus in there and you've got a binomial, it does have to go to both of those. And then we can kind of solve from here. So I notice I have 4r minus r over here. I'm going to simplify that and make it 3r minus 4. This is 8r minus 12. Okay, so it was a lot of work, but now we have this down to stuff. So yes, we can do lots of things. I like to start with the r's just because that makes my brain happy. And so I'm going to subtract the 3r from both sides first, which leaves me with 5r minus 12 equals negative 4. And then add 12. You could totally add 12 first if you wanted to. It doesn't matter. And then you get 5r equals 8. And what do we divide by? 5. I was kind of pointing at it, like trying to help you guys out. All right. And then we get r equals 8/5. You could make it 1 3/5, but you don't have to. We can just leave it improper like that. So what we want to do is kind of change it back to the equations that we started doing way back in middle school so that we don't have any fractions in there. Okay? So then going over to number 4, what would I multiply everything by? 4x squared. So we want to get rid of everything, so we're going to use 4 and x and squared over 1. We're going to distribute it out so that it's in all the fractions. So we're going to have 4x squared over x equals 4x squared over 4x squared. And then remember, we're just going to put that 4x squared in front of parentheses with the x plus 6 and kind of keep it separate, because that's just going to cancel out and we won't have to actually multiply anything. All right, so 4x squared over x, this x will cancel one of those, we'll get 4x. Over here, everything cancels, that gives me 1. It's never 0, there's always going to be something there. And then over here, the 4's and the x squareds cancel and leave me with x plus 6. So before you do anything else, you might want to put the 1 and the 6 together and make it x plus 7 or 7 plus x, either way. And then this is a whole lot shorter and simpler than it was. We can subtract x from both sides and give 3x equals 7. Divide by 3 and we get x equals 7/3. We just copy down this fraction. And that's where we're going to stop for part 1.